Hello, my name is Nick and I hope you're having a great day. In this video I'll be looking at the Diffie Hellman key exchange. I'll explain the theory behind this encryption algorithm, then implement it using the C programming language. This video is designed to be a simple explanation, so I won't be going into the advanced mathematics behind this algorithm. Okay, so what is the Diffie Hellman key exchange? The Diffie Hellman key exchange is a method of securely exchanging cryptographic keys over an unsecured channel. It is one of the earliest examples of public key exchange within cryptography. However, it had security issues because many applications that use Diffie Hellman aren't strong enough to prevent attacks from well-funded attackers, like national security services. The key generated in Diffie Hellman can be used to encrypt and decrypt communications between two parties. Key generation is based on mathematical principles, such as prime numbers and the modulus operator. You'll see how these principles are linked in my code later. So, how does Diffie Hellman relate to real-world applications? A common example is when a web browser connects to a web server, as the Diffie Hellman key exchange will be performed to exchange keys between the certificates of the browser and server. Now let's get into the inner workings of this encryption algorithm. I'll be going through the diagram that's displayed here. I'll be using liquids instead of numbers to make it easier to illustrate my point. First off, person A and person B start off with the same paint. This paint must be the same in terms of its volume and colour. Secret colour A is only seen by person A, and secret colour B is only seen by person B. The public can't see these colours as they're in the private domain. For person A, their common paint is added to secret colour A to create mixture A. Likewise, person B's common paint is added to secret colour B to create mixture B. Within the public domain, mixture A is given to person B, and mixture B is given to person A. Now, within the private domain, person B adds secret colour B to mixture A to create common secret B. In addition, person A adds secret colour A to mixture B to create common secret A. If common secret A and common secret B match, then the Diffie Hellman key exchange was completed successfully. What does the Diffie Hellman key exchange look like in code? I'll now create a C program that uses Diffie Hellman. Thanks for listening to this presentation. Okay, so here's my program that I wrote in C. I'll post a link to the program's source code in the description. I've created a function called key that will return a long integer. The mathematics here is complex, but I'll try to put it as simply as possible. It will first store a number as a long integer, which was inputted by the user as an integer. A long integer accepts numbers that are up to 8 bytes in length. I believe the numbers are between -9 quintillion and +9 quintillion, which is a lot. There are different operations performed if the number is even or odd. As you can see in this if statement, it's easier to perform a calculation with an even number compared to an odd number. So I'll just comment on line 3 that the algorithm is used to calculate the key. Okay, now let's get into how the user interacts with the program. First, I declare all the variables as integers, which are here, and afterwards both users enter their public variables, which are represented as n and g. And I'll call the users Alice and Bob, so I'll just comment Just to let you know, the names Alice and Bob are fictional names used as placeholders in cryptography. Once those variables have been entered, Alice types what integer her private variable represents. Her private variable is called x. Alice's key will be calculated using the variables g, x and n. So I'll just comment Alice inputs value for private variable y, x, Now Bob chooses what integer his private variable represents. His private variable is called y. Bob's key is calculated using the variables g, y and n. So I'll just type here Once all the inputs have been entered, two numbers are displayed to the screen, representing the key for Alice and Bob after the swapping process. If the numbers match, the Diffie Hellman key exchange was completed successfully. So I'll just comment Now let's run this program. So I'll be entering the values 23, 37, 4. As you can see, it worked because Alice and Bob have the same number, which is 18. Okay, so thanks for watching this video. Make sure to check out my LinkedIn profile and have a nice day.